Okay, so this is the first part of question 5. We've got this curve, which I might have a little look at. Power of x plus e to the power of minus x. And I might define that. And looking at a graphing window, okay, so that's what the graph looks like. So if this is happening, sequences, okay, so the half, yes, is a dilation by a factor of a half from the x-axis. So I'm going to rewrite this as f of minus x minus 2. Therefore, we have a reflection over the y-axis because x became minus x. Then we have a translation right, 2 units. Okay. Two functions g1 and g2 are created both with the same rule as g, but with distinct domains such that g1 is strictly increasing. So this is g1 because it's got an increasing gradient, and g1 is strictly decreased, so g2. So that's my g2, dividing g1 into two 1-to-1 functions. So if this is g1, g of x. Okay, so g of x is this. So let's get g of x, and g of x is going to be that multiplied by 0.5, and inside here I've got 2 minus x. And that's the rule. And if I drag and drop that, it's now got a turning point which is at 2 and 1. Okay, so it's now looking like this at 2 and 1. And that's now G1, and that one will be G2. I'm looking for the domain and inverse of G1. Okay, so the domain of G1 is going to be 2 to infinity, and the range of G1 will be 1 to infinity, and there's square brackets. Therefore, the domain of G1's inverse will be the range 1 to infinity, and the range of G1's inverse will be 2 to infinity, and that's the domain and range of the inverses. And lo and behold, I can now see they've drawn the inverse of G2 from here. So, and that's G1. Cool. And that's what G is. So we now know that that's 2 and 1. Therefore, that's going to be 1 and 2. That's the inverse of G1. That's okay. Find the coordinates of P and find the coordinates of Q. So if I take this and I make it equal x, P is going to be the intersection of G with x and Q also. So interactive advanced solve, and I get 1.27. P is 1.27, and it's on the line y equals x, so y equals 1.27, and that's rounded to 2 decimal places, and 4.09. And Q is 4.09 and 4.09. Okay? And find the area of the region bound by the graphs of G1, or G, inverse 1 and inverse 2, corrected to 2 decimal places. Okay, so I want this area here. And I'm going to say that if I say that this is A and this is B, then I want 2 B's. So the area is going to equal 2 B's, which is going to equal 2 lots of the integral from 1.27 to 4.09 of x minus g of x dx. And that's going to give me an answer which is, if I grab the line y equals x, and I grab this line here, and I do analysis g solve integral from the intersection points, except the first one, go across to the second one. There's my area. 2.78, and I multiply that by 2 because I want 2 of them, and I get an answer which is 5.560909335, and I want 2 decimal places, so 5.56 units.